Solve the combination inequalities and express the answers both in interval notation and in set builder notation. A combination inequality is essentially two inequalities that are being considered at the same time. In this first example, we're looking at both the inequality 3x plus 2 over 2 is less than or equal to 4, and at the same time, we're looking at 3x plus 2 over 2 is greater than, strictly greater than, 0. To solve this combination inequality, the idea is that we're going to isolate the variable in the center of the inequality, and anything that we do to isolate that variable has to be done to all three areas. Essentially, we need to do the same thing to both sides of this inequality and this inequality. So to solve both at the same time, we need to do the same thing to all three areas. The first thing we're going to do is we're going to clear the fractions by multiplying all three spots by the LCD, which is a constant value. Since there's only one denominator, the LCD is a positive 2, remember we can only multiply an inequality by a constant, not a variable quantity. So because our LCD is a constant, we are allowed to clear these fractions. So this multiplier of 2 needs to be multiplied on the far left, which is going to give us 0. Because the 2 is a positive quantity, we do not change the direction of the inequality. Then we multiply 2 by the innermost expression, and here the 2's are going to cancel out. So what we end up with in the center is just 3x plus 2. Again, because the 2 is positive, we do not change the direction of this inequality either, so we still have less than or equal to here. And now we multiply 2 by the rightmost quantity, which is 4, and 2 times 4 is 8. Now we continue to try to isolate this x in the center here. So let's subtract 2 to get this x by itself, and remember we have to subtract 2 from all three places. So the 2's cancel out in the center. We have 3x now by itself in there, and 6 on the far right, and negative 2 here on the left. Now in order to completely solve for x in the center, we're going to divide all three spots by 3. The 3's cancel in the center, and we end up with, on the left here, negative 2/3, strictly less than, x in the center by itself, less than or equal to, and 6 divided by 3 is 2. Now it's time to express the answer in interval notation, and before we do that, I strongly recommend that we graph the solution set on the number line. We're looking at the x's that are less than or equal to 2, so we're going to have a box here to indicate that we are including the 2, and we also want the x values that are strictly greater than 2/3, so we're going to put a parenthesis here, and we're looking at all the values that are in between these two. So when we go up to express our answer in interval notation, notice that it's going to look very similar to what we see on that number line. We're starting at negative 2/3, we do not include it. We go to the largest value in the solution set, which is 2, and we do include that with a bracket. Again, notice the similarities between the interval notation and how that solution set looked when we graphed it. Now, in order to write our solution in set builder notation, we always start with the same template, which is a curly bracket, which stands for the set of all x's. The vertical bar means such that we're going to leave space in the center for the criteria, and then we close the set with another curly bracket. The criteria field is where we put the inequality version of our solution. So we're just going to copy paste this inequality into the criteria field of the set builder notation. And these are our answers written in both set builder notation and interval notation. So let's do this again for part B. Again, we're going to try to isolate the x quantity in the center. We could clear the fractions by multiplying by the LCD first, or we could subtract 1 from all three places first. I'm going to do that, but either start point would be fine. The 1's cancel here in the center. We're going to have negative 2 on the left, less than or equal to negative 1/3 here in the center, strictly less than 0 on the right. Now we do need to clear this fraction. And in order to do that, let's multiply by the LCD, which is 3, but let's actually multiply by a negative 3, which will then also cancel the negative in the center, leaving just the x by itself. Remember, multiplying an inequality by a constant is okay, but we would not be able to clear the fractions if the LCD contained a variable. You can't multiply both sides of an inequality by a variable quantity, and that's because we don't know whether or not that would cause a sign switch. So the LCD multiplied by -2 over here on the left is going to be +6, but because we multiplied by a negative quantity, we are going to get a switch in direction on the inequality. So now this is going to be greater than. Multiply -3 now by the center expression. -3 times -1/3 is +1, so we just end up with x in the center. Again, because we're multiplying by a negative quantity, it is going to cause the direction of the inequality to switch. So this one becomes a greater than symbol. And now we multiply -3 times 0 to get 0. Now here we'll see the benefit of first graphing our solution set on the number line, because multiplying by this negative caused the inequalities to switch directions, and that kind of scrambled up who is the smaller quantity. 0 is smaller than 6, so it is actually to the left on the number line. So we're actually looking for the x values that are greater than 0 but also less than or equal to 6. So the quantities that are in between 0 and 6 are here, with a parens on the 0 and a bracket on the 6. Again, when writing the solution in interval notation, we'll notice that it looks very similar to the graph on the number line. We start with the smallest quantity in the solution set. In this example, we're not going to be including the 0 because we had a strictly greater than symbol here. Then we go to the 6, which is the largest value in the solution set, and that's going to be wrapped up in a bracket. When we write the solution in set builder notation, we again begin with a curly bracket, which means the set of all x's such that. Now the criteria field is where we can put the inequality. I'm actually going to rearrange these elements so that the smallest value is on the left and the largest value is on the right. And to do that, we had to flip the inequalities. Again, it should match the graph of the solution set on the number line. So this is our answer in interval notation and the solution written in set builder notation.